Today we'll be showing you how to complete projectile motion word problems. First, we'll start with a scenario where you are given a quadratic equation in standard form. So f of x equals negative x squared plus 8x. To get a better picture of what standard form looks like, add in 0. From this, we can conclude that it is a quadratic equation that opens downward because the leading coefficient is negative and there is an x squared. It also shows us that there's an x-intercept at 0, 0 and another at 8, 0. These can be found by factoring. To find the maximum, we use the coefficients based off standard form. So we know that standard form is ax squared plus bx plus c. Vertex form is negative b over 2a. Substitute using the coefficients from our original function. We know that 8 equals b and negative 1 is a because the negative basically means negative 1. Simplify and we get 4. Vertex form only gives us our x value, so to get our y value, substitute x as 4. Our y value comes out to be 16. Therefore, our maximum is 4, 16, which also is our vertex. Let's say in a word problem, the x equals time, minutes, and y equals height in feet. We wanted to know at what time a ball would be in the air at 7 feet. Just set the equation equal to 7 and factor, and we get two answers, 1 and 7. That means at 1 minute and at 7 minutes, the ball is 7 feet in the air. To show a more graphical sense, here's the x-intercepts, the maximum, and at how many minutes our ball is at when being above 7 feet off the ground.
Now let's say you aren't given the function. You will have to find it algebraically. To do this, you need two things, the maximum and one other point. For this problem, the maximum is 310 and the other point is 0, 1. We'll be using the vertex form of the quadratic function, so y equals a parentheses x minus h parentheses squared plus k. H is the x value of the maximum and k is the y value of the maximum. Plugging in h and k values will get you y equals a parentheses x minus 3 squared plus 10. Now we need to find the value of a. To do this, plug in the other point you are given. So 1 equals a parentheses 0 minus 3 squared plus 10. 1 equals 9a plus 10, and then negative 9 equals 9a. So negative 1 equals a. So our final function would look like y equals negative parentheses x minus 3 parentheses squared plus 10.
A boy tries to throw a ball as high as he can at his friend 8 feet away. Each of the boys are 3 feet tall. The ball reaches a maximum of 4 feet away at a height of 51 feet high. Find the function. Let's define our variables. X would be the distance in feet, y would be height in feet.
Okay, so now let's find the equation algebraically. So to do this, you need the max and another point. The max is 451, and the other point, which is the y-intercept, is 0, 3. And the standard vertex form is f of x equals a in parentheses x minus h squared plus k. So we know that the h is 4 and the k is 51 from the maximum. So we just plug this in to the standard form, and we have to solve for a, which controls the vertical compression or vertical stretch. So after you plug that in, you just solve for a. A equals negative 3. So the final function will be f of x equals negative 3 in parentheses x minus 4 squared plus 51.
Say a flagpole was 2 feet away from the boy throwing the ball. At what height will the ball hit the flagpole?
So now we have our function, which is f of x equals negative 3 in parentheses x minus 4 squared plus 51. So the flagpole is 2 feet away from the boy. So we can say that that is x equals 2. And basically we just plug in 2 into the function. So f of 2 equals negative 3, and then 2 minus 4 squared plus 51. And now we basically just simplify, and negative 12 plus 51 equals 39. So you should get f of 2 equals 39, which means that the boy hit the flagpole with the ball at a height of 39 feet. So basically your point is 239.
Graphically, we know 3 points, 0, 3, and 8, 3 for the two boys, and we know the maximum, 451. Through finding the height of our flagpole, you can graph 239. So that's it. Thanks for watching.